Okay, let's look at this question. It says the value of x, y, and z respectively in the expression m raised to the power x, l raised to the power y, t raised to the power z for the universal gravitational constant g are a minus 2 minus 3 minus 2, b minus 1 3 minus 2, c minus 1 2 minus 3, d minus 3 minus 1 minus 1 3. For us to be able to solve this question, you must know what universal gravitational constant is, G. You must know the units. If you don't know the unit, you cannot solve this question. Even though we have not done this in this class, but I want to use the opportunity to introduce something. Have you heard of Newton's law of universal gravitation? So it's simple. State it. State the law. What the law states?
Like, what goes up must surely come.
Yes. But do you know the equation, the formula for gravitational force? Let me explain. Newton is trying to let us know that in the universe, that each particle in the universe, each body, everybody in the universe attract each other. That's what Newton is trying to talk about. And that there's force of attraction between different bodies in the universe. So if we have two particles in the universe, the two particles, that's a force of attraction, that they tend to attract each other. Now that's where he proposed that law of universal gravitation. It states that the law states that the force of attraction between two bodies, M1 and M2, is directly proportional to the product of their masses and inversely proportional to the square of the distance between the two bodies. Now, if we have two bodies like this is body A or body 1, and this is body what? 2. And this particle here has mass M what? 1. This body here has a mass M what? 2. And this is the distance between the two bodies, which is what? R. Okay? These are the two bodies, body 1, body 2. This is the mass of the first body, and this is the mass of the second particle or body, as case may be. This is the distance between the two of them. Now, Newton's law of universal gravitation is saying that there's a force of attraction between these two bodies. They attract what? Each other. So Newton's law is saying that this force, remember we did variation. That's why anything you do, don't joke with it, because it will keep coming back again. You keep building on what you have done. So we did law of indices here. If you took it seriously, you realize you will realize that we have been applying law of indices throughout all this while, right? Now you need to apply variation here. Now, Newton is saying that this force is inversely proportional to the product of these two masses. The product of the mass of the first body and the mass of the second body, which is what? M1, M2. And inversely proportional to the square of the distance between these two bodies. Distance between the two bodies is what? R. So square of what? R. This is what Newton's law of universal gravitation states. that the force of attraction between two bodies or particles of masses m1 and m2 is directly proportional to the what? Product of their what? Masses, and inversely proportional to the what? Square of the distance between what? Two of them. Now we need a constant here for this to be an equation, right? Remember, this is just a proportion. For us to remove this sign of proportionality, we do what? We introduce a constant, and the constant we are to introduce here is known as what? G. G is the constant we introduce. So this G is what we do call what? The universal gravitational what? Constant. So to make this an equation now, F becomes what? G what? M1, M2 by what? This is the equation. Newton's formula for what? Force. This formula give the formula for what? Gravitational what? Force. Is it clear? Now we are told that if the value of x, y, z respectively in the expression m raised to the power x, l raised to the power y, t raised to the power z for the universal gravitational constant G are which of the following? To do this, remember the type of equation we did. There's one this in law of indices we did that time where we said that power if the base is the same thing, the power you can equate the what? Power. Can you remember that thing we did? That's one law of question we solved here on law of indices where we got a particular question has some alphabet in the power. We need to do what? We say that if the base are the same thing, you can equate the what? The power. Are we together? Now what we do is we find the dimension. For us to solve this question, we will find the dimension for what? G. Okay? We find the what? Dimension for what? G. And for us to find the dimension for G, we need to find the unit of what? G. And how do we find the unit of G? We make G here the subject of the what? Formula. If we make G the subject of the formula, we now replace all those units, all those quantities with their what? Units. That will give us the unit of what? G. Then from there now we now find the what? Dimension of what? G. Now let's do all these things I said now. From this formula now, from here now we come to this place. G becomes what? G becomes what? F what? We cross multiply, right? F times what? Reduce. Force times what? Reduce raised to the power what? 2. All over what? M what? 1 M what? 2. M1 M what? 2. Is it clear? Now let's put their units. Remember that Newton is force, right? Remember that force, Newton is just force. We need to split into Newton. Hope you know. Are we together? We need to split down what? Newton. If we split Newton, what do we have? We have what? Mass, right? Let's do it here. We have what? Mass, what? Times what? Acceleration, right? Times what? Radius square. True of us. All over what? M1 times what? M2. So having split it down, let us now replace this thing with their what? Unit. What is the unit of mass? Kilogram. Times what is the unit of unit of acceleration? Meter per second square. So we have what? Please, if you're not following, come and attention, okay? Except someone that came late, I won't answer you. But if you are here before us and you're not following, do what? Ask what? Question. Kilogram times what? Meter per second square. So we put acceleration, which is what? Meter per what? Second square. Are we together? Then times what? Radius, which is what? Radius square, right? All over what? M is what? No, sorry, radius has a unit, right? What is the unit of radius? Is radius a measure of distance, length? Yes, now. It's when it's not a distance. It's measured in what? Meter or C or centimeter. But we are using SI unit. So the SI unit is what? Meter. So we now put unit of velocity as what? Remember it's squared. Meter what? Meter what? Squared, right? Remember it's squared. All over. This is kilogram into 2. So it becomes what? Kilogram what? Squared. Or simply write what? Kilogram times what? Times what? Kilogram. Is it clear? Now, having got to this level, let's cancel out and see what we get. Kilogram here will do what? Cancel kilogram here, right? Right? Are we together? Are we together? So we are left with what? There's meter here. There's meter here. So we have meter what? There's meter here. There's meter square here. So meter times meter square is what? Meter what? Meter what? Meter what? Cube. Good. Meter times meter square is what? Meter cube. We have this, there's per second here, right? Which is what? Per what? Second. But if you look at this place, we have kilogram under. Everything is kilo over what? What do we do to this kilogram for it to come up? We have meter cube per second squared over kilogram. We want it to be on a straight line. You use law of indices. What happened to the kilogram? You do what? M is meter, not kilogram. And that M is not mass. So we are dealing with units now. We have left the quantity now. We move to what? Units. So I ask a simple question. Using law of indices, if you have M cube per second square over kilogram, you want it to be on a straight line. What will happen to that kilogram? How will it come? What will it now become? Minus. You have issue with this minus. Is it minus or power? If you say minus, see what you mean by minus. Let me write what you just said now. See what you just said. M cube S cube minus kilogram. Is that what you meant? No, it's wrong. Someone should tell me what should be there. Raised by minus 1. Yes. Law of indices. If you have 1 over say kilogram, what should it be? It's not kilogram per kilogram. Remember the inverse law now. Per kilogram. True or false? Negative power. So let's do it here. This becomes what? Per what? Kilogram what? Meter cube per what? Second square. This is where we have arrived. As the unit of what? This is the unit of what? This is the unit of what? Gravitational what? Constant. Remember we are all this we are trying to derive the unit of what? Gravitational what? Constant. Now, having got to this, remember what we said, that kilogram, put it in dimension. This is units. Look up. Understand what you are writing first before you write. This is units. We want to move this unit to what? Dimension. So what do we do to this unit? Remember that kilogram is what? In dimension. Is what? M, capital M. So we have M what? This is minus what? 1. Meter is what? L, right? So we have L, this power what? 3. Y seconds is what? T. We have per what? T squared. Now this is dimension. This is dimension. You cannot see the board. Now this is dimension for what? Gravitational what? Constant. The universal gravitational what? Constant. This is the dimension. Now for us to find x, y, z, we will carry this dimension and equate it to what? Equate it to what? M, L, Z. M raised to power x. L raised to power y, and T raised to power what? Z. The one that have the same base, the power will be what? The same thing, okay? So now, let's now equate it. If you carry this in now and equate it to this one now, you get something like this. M raised to power x, L raised to power what? Y, and 3 raised to power z is equal to what? M raised to power what? Minus 1, L raised to power what? 3, and T raised to power what? Minus 2. Do you know what this means? This M raised to power x and M raised to power equate. You will equate M raised to power x to what? M raised to power what? Minus 1. That means that x is what? X is what? Is what? Minus 1. Y? This one has L. This one has L. So y is what? 3. Y is what? 3. Y the T raised to power z and T raised to power minus 2. You equate them. That means z is what? Minus 2. So the x, y, z are what? Minus 1, 3, and minus 2. Is the answer there? Is the answer there? Which option? Option what? B. That's the answer. So for you to answer this question, you must know Newton's law of universal what? Gravitation. From there, you should be able to know we are what? Universal constants. Know the formula for universal constant, as in know the units, then move it to what? Dimension. With that, you can now determine the value of what? X, Y, and what? Z. With that, you can determine the value of what? X, Y, and what? Z. For those that came early, any question? For only these two people, I'll answer their question. Others, you came late, I won't talk to you. Those that came on time, any question? Any question? No question. Next time you come on time. Now let's go to the next subject for the day. We are done with physics review. I think that this is. I even added something extra self to the. You have question on what? What is that? Which question I asking? Let me even know whether if once is what we did before you came, I won't talk to you. What is the question you want to ask? Sorry, I won't talk about that. I told you don't come into my class. Sorry, I will not talk about it. Lie. That's punishment for coming late to my class. Next time you come on time, 4 p.m. will start, okay? And I need to discipline you. You need discipline. So you don't do things anyhow. All right, please copy. If you are done, let's go to the next subject. For those that came here, any question, no question, I will end physics here. Okay? All right, see you next time.